Martin, and welcome to another great edition for Astronomy for Beginners. And today we're going to do a DIY guide on the latest ZWO ASI120MC. Now this is a very good planetary camera. This is a coloured one and it's used very extensively for high-res images of planets. However, I've been trialling this camera for a couple of weeks and I'm starting to use this camera not only for imaging planets but also using as a dedicated, a deep sky object imager. Now a lot of the CCDs you can get that's purposely for deep sky imaging are very expensive, and you can look around for a price minimum of around about £320 to about £370 for a really basic one. However, if you want more high quality images and more cooling and all that and other things, then you need to start investing into a CCD imager to about £1,000 plus. So it's very expensive and it's beyond most amateur astronomers' budget. However, I've been testing this camera out for a few weeks and I'm absolutely impressed on how it's performed. Despite having no cooling, which is the big major drawback of this camera, using ShortCap 2.1, I'm capturing images, deep sky images of M51, the Leo triplets, and many more of these faint galaxies using this camera. Now, with the ShortCap 2.1, it can be used as a planetary imaging capturing software, but when you extend the exposure rate, you can extend this camera to 1,000 seconds, which is a lot. Usually on a good day, 600 or 300 seconds is more than ample to capture all these faint fuzzies or nebula and get all the hidden detail. So you can achieve wondrous results with this. Now what we're going to do is we're going to take a look at the images that I've taken using this camera, alright, and you'll be quite impressed what you see. And there's a lot of members out there on the Facebook group on Astronomy for Beginners have seen these images, but again, see what you think, because personally it's something else, this camera. So we're going to take a look at these images. So now you've looked at the series of my images, and what do you think? It's really quite impressive what you've seen, and for a camera that's only designed for capturing high res of the planets and all that, and used as an auto guider, I'm quite impressed on the images. I'm that convinced that the images that's produced from this camera actually is better than the QHY8L, which is saying something, because that is a dedicated deep sky camera, and it being a CCD. Now this is a CMOS camera, and CMOS have renowned for many years ago not being very good quality. However, today's CMOS cameras is the latest chip electronics being introduced, and there's a lot of these CMOS cameras are now coming out, and they are excelling better than the CCDs. Because of this CMOS chip, this camera is producing very good high-res images. In other words, this delivers around about 3.7 microns, around that value, which is very fine detail. So when you connect this to the telescope and you're taking high-res images, because of the pixel size being very small, you can get really good fine images with this camera. And for the past few weeks, the more and more I use this camera, the more I feel attached to it. And being a dual purpose camera as it is, right, the ZWO is fantastic. It's a camera that I think, for someone who's starting out, who wants to invest in a camera that's going to deliver some good images, can be used as an auto guider, can be used as a planetary imager, and now can be used as a deep sky imager. You can't ask for a camera for the price. I mean, 240 to about £270 for this camera sounds a lot, but the stuff that you can get out of it is something else. Now, at the moment, because the chip is very tiny, it's usually restricted to a certain amount of cooling periods. 5 and 10 minute exposures is usually okay for this camera, but when you want to go even deeper and capture even fainter fuzzes, then the noise level really builds up. And also, if you look here, I fitted a 0.5 amperes photocool reducer. The reason why I fitted this is that even with fitting it onto my 80mm ED doublet refractor, the chip is very small, but increasing the size is just enough to get all the triplet galaxies in there, just enough size to fit M42 and M43 Great Orion's Nebula, which is quite big, but it only just fits. That's the reason why I fitted onto this. Because I fitted the photocool reducer, it also speeds up the light gathering, collecting the photons quicker. It makes my Lunt 80mm an f7 to a f3.5, which makes my optics capturing all that data ultra fast. So I can capture quite a lot of data. Say like if I'm capturing data of 2 minutes through this camera, compared to another telescope. So like if I kept it with the f7 on the refractor, I'm probably 5 minutes to get the same sort of level of detail. So it just shows you that in putting a photocool reducer will help to speed up the light gathering and the data quicker. And the thing is, it might make the images smaller, but you can always edit it by cropping the image slightly to get a bigger picture using Photoshop. Now, I've been testing out this camera, and I've come to a conclusion that I think you could do more. And at the moment, there's not much information out there on modding this camera. Now, a lot of the expensive cameras you see, the CCDs that are used for deep sky imaging, is that they have a Peltier cooling fan systems. So in other words, these systems have a built-in fan, electronic controlled tech fan. It has a Peltier system, like a cooling element, and basically this cooling, can cool down to about -10 to about even -70 degrees. So basically it cools it down to a point that when you're capturing long amounts of data of 10 minutes and more, you're going to get, it will reduce all this camera noise. So basically if you're capturing the image, you see the raw image on the computer screen and you start seeing pixelated red dots or squares or green and blue squares. That is the noise, and the more you increase the exposure rate, the more that noise comes out. Now this is where the camera with the built-in fan system will try to eliminate as much of this noise as possible. So increasing the cooling will help to reduce the noise factor. Now I had a brainwave and I've researched through the net and there isn't much information on modding this camera. However, as I highlighted on my last guide on the review of this, I did highlight these four metric 4 threads, which tells me that you can adapt some kind of cooling device onto there. With this Peltier fan cooling system, you could probably achieve cooling for this camera. So I've done a bit of research, I've done a bit of maths, I've been working out a circuit diagram on using Ohm's law and things like that, and I've come with a plan, and I'm going to show you how you're going to fit a basic Peltier cooling fan system, but it's just a basic system which will help to aid better cooling for the camera and help you to eliminate as much noise as possible. Bear in mind, it's not going to eliminate every single noise on the image itself. You still have to take dark images. So again, I'm going to show you a cheap way to modify this camera, and the best thing about this camera, when you mod it, you are not going to interfere with the electronics in the camera itself. So basically there is no requirement to strip this camera out, because the camera has an aluminium body, which means is whatever cooling that is involved with this camera is that the heat, the cold air or whatever is going to warm up the actual case itself. So basically, because aluminium is a very good conductor of electricity and heat, it will basically help to cool the entire camera. So there is no requirement to strip this out. So what I'm going to do is I'm going to show you a step-by-step guide. First off, I will show you the tools and equipment you're going to need, and then I'm going to show you the prices which of these components you're going to need, and then I'm going to show you the circuit diagram, and I'm going to show you a live picture of that circuit diagram so you can relate it to the circuit diagram to the actual image, so when you're going to wire it together. This is the basic system. This will help improve the camera's performance, and please feel free to undertake this project. So we've been the only video guide to demonstrate this mod. Alright, please feel free to undertake it. I've worked out within budget for most people, so it's not going to break the bank. So what we're going to do now is we're going to take a closer look on the equipment, the parts you're going to need, and the tools you're going to need as well to do the job. So we take a closer look. Hi everyone, I'm going to show you a little presentation on how to make a Peltier cooling system mod for your ZWO ASI120MC. And basically I'm going to show you the parts and the components you're going to need whilst undertaking this modification. First off, I'm going to show you that you're going to require a set of wires to connect your electrical circuit,
This will form part of your main wiring loom, and this is colour coded in black and red. Black is the negative lead and obviously red is the positive lead, and basically it's copper insulated wire. You need between 2 meters or 3 meters of copper insulated wire, and you don't have to have them in different colours. However, I did it in different colours so that you can see which of the circuit goes, which helps you when you connect your circuit, you know which wire goes to which to the components. So the of the components that you're going to connect, you're not going to reverse connect them in the wrong way that you risk damage your components. Again, the wire is very good quality. Be sure to get the right sort of thickness, between 0.8 to about 1 millimeter thick diameter wire. You don't need heavy duty wire. This will do. This is very typical to a lot of electrical circuits, and it's very durable. Then I'm going to show you another way to power your actual modification. I would recommend that you have this running on a cigarette lighter plug, 12 volts with at least a 2 amp or 3 amp fuse installed. Now this will connect your fan onto a power tank or an external battery, and basically this will provide 12 volts with that fuse and will protect the actual modification if it blows. It is actually very easy to put together, and it is worth that little bit extra to invest in a cigarette lighter plug. With this plug protecting your circuit and avoid damaging your components. It's not very complicated to connect this together with your wiring, and I will show this in the guide. But if you're going to power up your fan, I suggest that you invest on the cigarette lighter plug unit. Then, as part of my wiring loom, I'm going to install these. These are a race PK lead. It is a 2-pin connection. Basically, one has a male end and the other has a female type end, and basically these will help to connect your wiring together. This can be formed as a switch, and with this switch is I can disconnect the main wiring loom if I wish to use the fan for taking deep sky objects or photos of there. Or if I want to use the planets, if I'm going to image with the planets and the moon, I can just quick release and disconnect the main wire from the fan unit. Very easy to do, and again it's colour coded with a red and black lead to indicate the positive and negative ends. I would seriously recommend to invest on some of these. You don't have to buy them. Again, these will help because they fit one way only. You cannot reverse connect them in a different way and risk damaging your circuit on your cooling fan. So I highly recommend that you invest in a set of clips like these. Then to move on, you're going to require some kind of mechanical securing devices, and this is your just normal screws or bolts. These are usually stainless steel. Go for the stainless steel type fixings because they don't rust, and plus it gives a nice finish to the camera. Again, these are metric 4 screw threads. It's M4. The threads will fit perfectly onto the back of the ZWO ASI120, and I've got mine in 35mm long because of the components. So if you do buy a set of bolts or screws, just check the length you're going to need required. Basically just check your components that you got, but basically by checking the thickness of your components, and you can get the desired bolts you need. Alright, and this will help to secure everything in place, so it gives a nice neat finish. Again, just normal bolts. Then you can find these. These are an aluminium heatsink. These are usually found on a lot of computer systems, particularly in your own PC. These are heat sinks that are connected onto your CPUs, your processors and all that, and all your chips. And basically these will help to aid cooling and basically to reduce overheating. These are made out of aluminium, which aluminium is a very good conductor of electricity, but also they're very good at thermal properties, which will, again, they will dissipate the hot heat, and also so they aid cooling to protect processors. Again, they don't cost much money. It is very important that you install one of these as part of the modification, and will help improve the cooling of the camera. Again, I've got them in various sizes, but these sizes here indicate the 37.5mm by 37.5mm. Basically, it is the height and width of the heat sink itself, and the times 5.8mm is the actual depth or the thickness of that heatsink. Again, I got the smaller heatsink, which is slightly smaller. However, reasons I got it slightly smaller is that it fits perfectly with the Peltier cooling cell. These dimensions fit perfectly actually on the camera. You can go bigger sizes, but that just depends. But the main thing is, as long as it fits in place to suit your needs, then it's fine. However, they don't cost very much money, and you must fit these parts onto the modification to gain the best possible cooling available. Now we move on to the first part of the main cooling part of the modification. This is a 12 volt 3.3 amp Peltier cooling cell. Basically this Peltier is basically provides refrigeration, so it works like a fridge. In other words, it will provide the cold air through electric current, and basically will provide the temperature, and makes the temperature of your camera, will provide the temperature of your camera much colder. But be warned, this device has two sides. This side here with the actual number in place in front, that is basically the hot side, which will provide warm air, and then the other side, which has no serial number, will provide the cold air. So please, when you fit this device, that you first check which side you're going to apply. Now, you don't want the camera to be warm, you want the camera to be cold as possible. So you basically want the cold side to be touching the camera's main body, and this will help aid the cooling. Very simple device. You can get this component from Maplins as a cooling kit. However, it costs £13 for this kit. So have a look around, look at a lot of electronic shops around. You'll be able to find this as a separate unit for about £3 to maybe £6. It doesn't cost that much money, but again, this is very important, this component, which will help to aid cooling. So then we're going to move on to this device. So we come to this secondary cooling component to form the actual modification, and you're going to require a 12 volt 0.15 amp 50mm DC or direct current fan, and basically this fan is the correct size diameter, which will fit directly onto the ZWO ASI120MC. Now, you need to get a fan that gives out 12 volts and needs to be a direct current. So basically, one way you can tell is it has a separate red and a separate black wire that represents the positive and the negative leads. However, this can be operated by battery power if you wish, but you need to get this type. Now this can be secured with 4 metric screws easily, and also the fan is a brushless fan, which means it gives off a lot less noise and also reduce vibrations. It spins at 5,500 RPMs, which is very fast, but because it's a brushless fan, it will give off a lot less vibrations, which you do not want in your images, because basically if you get vibrations on your camera, you'll introduce blurring into your images, and you don't want that. You may wish to fit a smaller fan, but you might find that you might need to make a bracket to fit it in place. The 50mm diameter of the fan gives out enough and it fits perfectly and aligned with the screw holes. So I recommend that you invest on this type of fan. You may wish to put a bigger fan, but you may struggle to fit it by some means. Then we go move on next. Now I've highlighted this before in many of my video guides, and this is basically a spiral cable wrap. You only need a little bit of it, of 2 to 3 meters, and basically this spiral cap is 3mm in diameter, and basically what this stuff will do will help not only secure your cables of your wiring looms when you put it together. Basically it gives a nice, keeps your cables nice and tidy, but also will protect them from further damage. So I would highly recommend that you, for a little bit of money, just to invest on a set of cable wrap, so you can make your leads nice and well protected from the elements as well as other things. As I mentioned before, the battery pack is optional. If you want to install normal batteries as your battery source, you can do. There's no limits on your design, but remember, one important goal is make sure you get the right voltage of your batteries, and to do that is by checking the actual voltage rating on each batteries, and make sure that whatever circuit you're powering at, make sure that all your components are satisfying a certain amount of voltage. So in other words, if I was going to fit AA batteries or a C or D cell batteries, so if I want to ensure that I get the right voltage for my electrical circuit of 12 volts that I'm going to need, I'm going to require 8 of those batteries of 1.5 volts to get the right voltage I need. Also, be careful to check the actual batteries, because there are so many different types of batteries, from NiCad to alkaline to even lithium batteries. They all give a different voltage rating, and also they also give a different ampere rating. So please check each battery systems before you start installing and using batteries, because again, if you don't get the right voltage or the right ampere rating, if one of your components will blow, it's probably due to the fact there is either too much voltage or too much current. So please check the batteries. However, I would not recommend using batteries, because one, you'll have to recharge them more often, and also the cost of batteries are very expensive, and if you're running this type of fan, you will go through batteries like no day tomorrow. So I wouldn't recommend using batteries as your main source. I would use a power pack or a power tank battery unit, which will provide a lot more power for a longer duration. Then I'm going to move on to this little component. This is called a resistor. this is very important in protecting your components of your circuit, as if you don't want too much current to go through a particular part, and say like one of your components only runs at a certain amount of voltage or current. However, this device, what I've got, reduces the amount of current, then I would recommend that you invest in putting a resistor or some form of protection to protect certain parts of the electrical circuit. Again, this is a 5.6 ohm resistor. I will explain later on how to work out the resistance of the circuit and show you a very detailed diagram on why we fit this kind of component. Again, doesn't cost much money, and the good thing about this device is it doesn't matter either way. You can connect this component by either soldering the wires onto these two wires together, or you can crimp them with the wires. It doesn't matter if you get them on the wrong way round. This device can be connected either way and will work. So again, costs a few pence and will protect your vital components of your cooling system. As I mentioned before, I will demonstrate on how to connect your wires together by either twisting them together by hand and then using electrical tape. However, not a very good idea if you're using that process, because one, it's a bit of a messy job, and two, they're not very well secured. However, these are wire connectors, and basically what these do, they will connect two jointed wires together with a nice neat finish, and will also will give out a much better hold on the wires, more security. Again, they don't cost very much money, only a few pence, and it's recommended that you use these connectors. They're very easy to use. You can either use an electrician's crimping tool, or you can use a set of pliers and carefully crimp the ends. Once you lined your wires into these little holes on the side here, once you've lined them up, you just crimp them together, and it gives you a nice good security hold on the two wires and forms a nice electrical connection. Then we move on. I basically have made a shopping list of all the parts you're going to need whilst you undertake this modification. These are detailed at UK retail prices. You may find this very useful because it gives you an idea on the components that you're going to need whilst doing the modifications. You may find cheaper options, cheaper prices, but please shop around. The most I can get was £33.92. You may find cheaper parts or components out there for a lot less money, probably in the region around £20 to about £35. But again, this is a nice little shopping list that gives you a good idea on what to get to while you undertake your project. So we'll move on to tools and equipment required. And again, you're going to need a good old soldering iron. This particular tool will help you solder your electrical wires and your electrical components within the electrical circuit together, and applying a bit of solder. This, however, ideally get some soldering iron with a nice needle tip end, so that you can finally work with the solder nice and easily. Again, be very careful when you're using this particular tool, especially if you've got kids around. Make sure that that they are supervised whilst you're doing this job. If the kids like to undertake this, just parents, please give precautions. Please supervise your kids whilst they're using this tool, because if this tool gets used in a certain way, you can get burnt quite easily. we'll move on. You're going to need some soldering wire or solder wire, ideally with flux. Flux is a little additive that's in the wire that helps the solder flow very easily, so that it's easy to work with. So when you're applying your soldering iron and you connect your electrical connections of solder, this will flow very easily, and so it's easy to work with. You ideally get soldering iron, very thin solder wire. Do not get the really big thick diameter wire. This is too heavy duty and it's not adequate for the modification, and it may become a lot messy. So use very thin solder wire. You don't need a lot of it, and it only costs a few pence to buy, and you don't need a lot of the stuff. Probably half a meter is all you need, maybe a bit too much, but you don't need a lot of this stuff to undertake this project. Then we move on. Now, with me using screws, I'm using screwdrivers or cross point between a Phillips or flat type headed screwdrivers. Now it just depends on your fixings or whatever you're using that's going to secure your cooling fan. Because of the screws, I'm using good old Phillips cross points. If you've got bolts and you're using bolts, then you're going to need sockets or wrenches or spanners to secure your fixings. But I don't want to go far too much in depth on this, but basically check what components you have, fixings that you, and what tools you're going to need required to do the job. And then, because we're working with electrical wire, you're going to need the basic sort of tools. Now if you've got an electrician's crimping and wire cutting tool, that is fine, but ideally if you don't have that, you can always use a set of snips or pliers or wire cutters, so that you can cut the wire into different lengths and able to strip out the outer cable to give you the bare wire to work with. So you're going to need at least a pair of snips and pliers to do this job. Now I've done A-level mechanical engineering, and I never thought that I would actually use this formula called Ohm's law. Now I've done this a lot of times back in my college years and all that, and I never thought I would actually use Ohm's law to actually do this modification. But believe me, when I show you, it is very important that you need to do a lot of calculations when you're designing your circuit, and it's very important that you need to understand what is resistance and voltage and ampage within a basic parallel circuit. So I'm not going to teach people how to do electric principles or electronics or any of those things, but basically I'm going to show you a very basic guide for a lot of your members or viewers out there. So basically I want to keep it as a simple approach to explain this and to why we need to do this. And basically we'll move on. Now we have a series circuit, which is probably the most basic circuit you can undertake when designing this modification. Now, very simple. Here you have a battery, which is the power source, and it has a voltage of 12 volts, for example. Now, the voltage is very important. That is the power you need to operate your circuit. And without that, you're going to need amps, which is the current, which is measured in amps, and 2 amps is going to be used to power this basic circuit. Current is basically the moving power of moving that electrical power across the circuit. Without current, the circuit will not work properly. So you need current to get the electrical power or voltage across that circuit. Once it gets round the circuit, every electrical component will give off a certain amount of resistance against the voltage and current, so that for it to work. So you need obviously a light bulb or a buzzer or whatever it is that you're powering will give off a certain amount of resistance for it to work. However, with 12 volts going through this system, it will power this light bulb and it'll be very bright. However, once the voltage and the current passes through that, you'll find that the series circuit loses voltage, and in other words, there will be a voltage drop between each of the components within this series circuit. So basically, when you get to the second bulb, it might lose 6 volts, depending on the resistance of that electrical component. And again, if it goes through the other bulb, you're also going to lose a lot more voltage. So basically, what you're going to have is you're going to have a really bright bulb, a dim bulb, and an even dimmer bulb that might not be even working. But this is the main problem with the series circuit, is that you'll get that voltage drop. Also, the main problem is you relate this to a set of Christmas tree lights. If you bought cheap lights connected in series, what happens if one bulb blows, for example the first one blows, if that blows, basically you're not going to get any voltage or current going through that circuit, and basically preventing current and electrical voltage getting through and stops working. And that's the sort of thing I do not want to look at, is looking to a series circuit. You don't want a series circuit combined with this modification. Because I have two separate components, I want them to operate independently, and I will explain further on. So it comes to this one, and basically it looks a little bit more complicated, but it's not. It's still a basic system. This is called a parallel circuit. Again, you still got the 12 volts of your battery power source. You still got the moving power, the energy that you need to move that voltage across, the amps. And basically it goes through different connections within the circuit, and basically so now the electrical current will push the voltage across, and I will have 12 volts coming across through this bulb and light up, and basically that will go back to the negative leaf, back to the battery. Then the current will push again. This will happen simultaneously. So basically what will happen is, as the voltage and the current moves across the field, I will basically have 12 volts coming to each of the bulbs across the circuit, which is basically what I want in my modification. I want 12 volts independently supplying to the Peltier cooler and the fan system. So I want 12 volts running through that system. And the good thing is about the system, you notice there is no voltage drop, and if one of the circuits decided to open circuit or not work, for example, say like I have the middle bulb damaged, in other words it's not working, or if the bulb is blown, basically two of the lights will still work and I'll still get electrical power running through the circuit. These work very well with the modification, and the power circuit is the circuit I'm going to use on my cooling system. So I'm going to show you my basic circuit diagram. This is my circuit diagram that I've designed as part of my for my cooling system for my ASI120. And basically I have a 12 volt 12 amps per hour battery unit, which is a lithium battery, and basically that's going to have a 2 amp output, And the reason why I've done that is checked it through my lithium ion battery, and it's giving out a 2 amp output. And basically it will go across the electrical circuit through the switch. This switch represents my race PK connections, so it is a form of a switch. And obviously I have my current going through there and the voltage. There's the switch. Then the power will go through the Peltier cooler, providing the 12 volt supply. The Peltier cooler is designed to run at 3.3 amps maximum, which basically gives basically I do not want to over exceed that maximum because I'll risk damage the components. I have a built-in resistor as I described on previous frame. I have the 12 volt DC cooling fan. This will run at 0.15 amps and can run up to 0.5 amps maximum. However, if I run it on the maximum current, she will blow at 30 seconds, which I do not want. Which seems like a bad design for an electrical circuit, but all is not lost because I have a resistor there that's going to protect my circuit and risk damaging my cooling fan because of the current being 2 amps. So we need to calculate the resistor value. We need to find out how much resistance we need to control the current. So how do we do this? So using Ohm's law, it's basically calculations that you're going to use is to work out a voltage or a current or resistance within a circuit or electrical circuit. But we need to look at how we do this in order to protect the cooling fan. And basically I use a process called Ohm's law triangle. Now I've used a lot of other methods like transposition of formula to work out Ohm's law and all that, and using bod mass and all that, but I do not want to confuse a lot of you guys and girls. I want to keep this basic as possible so that you can undertake the calculations yourself. And it's very simple. The Ohm's law triangle consists of the V, which represents the voltage. The line here represents the divide. The I represents the current. The times represents obviously your timesing, which is the sum, and the resistance is that value there. And to do this is, here we have the triangle. Now whatever value you want to look at, so if I want to work out voltage in an electrical circuit, basically as long as I know the current and the resistance value in that circuit, basically I will, to find out the voltage, I would have I times R. It will give me the value of the voltage. The I, if I want the current, if I need to find the value of the current, then I need to get the voltage and the resistance, and what we do is we divide these values together, which will be V over R. But the one we're mostly focused on is this one, and it's basically we need to find out the resistor value or the resistance we need for that electrical circuit so we don't blow up the cooling fan. And again, we have the voltage of 12 volts and we have the current of 2 amps. So using Ohm's law to work out my circuit plan, that's the formula we use. Resistance equals voltage over I, or current. That's the value we have. The total resistance is 12 divided by 2 amps will give us a 6 ohm resistance. This 6 ohm resistor is required to stop 2 amps flowing through the 12 volt 0.5 amp fan. However, we do not want to completely stop the current flowing through the fan, otherwise the fan will just not work. So I looked at closer, and we need a value of 5.8 ohm resistor would be an ideal size to allow enough current to flow through the fan within the 0.15 limits. However, the fan can go on slightly higher ampage, but we do not want to exceed 0.5 amps. So you may want to choose to select a smaller resistor of 0.56 ohms, but please do not make that resistance smaller to allow more current to flow through, because basically if you get more current of 0.5 amps coming through that fan maximum limit, then you're going to risk blowing it. However, that depends on your circuit plan. You may choose another route and different parts than my plan. So you might want to fit a different fan than mine. So just check the amp rating of that fan or component, and check and watch your voltage rate. So again, always check your specifications and your limitations of your components. No matter what circuit you choose, it's the same calculation used. You may wish to have electrical circuit to run on more current, but check the amps limit of your components wisely. My circuit can run up to 3 amps and no more. Also think about the power drawn in the circuit. The more amps, the more battery amps per hour needed to run the Peltier cooling system, which means more current means bigger and heavier batteries needed to power the electrical system. And again, what I mean is, you decide on what options you take. Is if you're drawing a lot more power, so basically you're going to need a car battery to power a basic Peltier cooling system for your ZWO, which might not be adequate. However, something like a smaller lithium battery or a power tank that you get from the Skywatch or Celestron battery pack units, that's more than adequate. Here I've provided a photo of my actual circuit, and this is how it's going to be wired together. Again, you've got your battery power source or your cigarette lighter, and I will show you how you wire the cigarette lighter connector through my video guide. Here you have your positive lead, which is the red cable, and you have your negative lead, which is the black cable. Now the reasons why I did it color coded, so that I know which wires on the electrical components will be connected to, so that I don't cross the wrong leads connected to the wrong side and risk blowing the components up. So that's the reason why I've done that, so that one, you can see it clearly, and it helps me see it clearly how the circuit works. Again, I have a known value of 2 amps, and I have 12 volts running through this circuit, which basically, one thing that's not included in the circuit is the switch, which is the PK lead connectors, but it is situated here, and basically these wires will run across through the Peltier cooler elements and provide the cold air supply needed, and will go back straight to negative once it's passed through. Now the current and the voltage will go through here, as we calculated the set value of the resistor. Now you can either use a 5.8 ohm or a 5.6 ohm resistor, but that just depends on the amount of current that's needed within your components, particularly for example my fan. So again, using Ohm's law and calculating the resistance in your electrical circuit, if you're using different components, then you need to carry out that calculation, so that you'll need which size resistor that's needed to control that amount of current. And again, this will pass through, allowing only a certain amount of current to allow to flow through the fan, and will operate the fan, and basically the current and the voltage will run back to the circuit. So again, it's a parallel circuit. If one of these components fail, they're always going to have one that's going to be working right. So basically, very simple system, and I hope this image will help you understand my circuit diagram a lot more, and you can see it as a physical form rather than just a drawing. So, but basically, as you connect and you solder your wires together, this is how you will do it. But I will show you later on the video guide by step-by-step instructions, so that you can follow it as easily as possible, and you can achieve this modification. So that includes my presentation. We're now going to proceed through DIY guide. So we're going to begin working our circuit, and it just depends on how you want to design your circuit. I'm going to use the cigarette lighter, and basically I'm going to have this power off my my lithium-ion battery. You can use the good old battery pack, but make sure that your battery pack gives the right sort of voltage you need. At the minute, this does not give the right voltage. This, however, does run the circuit, but it's just not enough power, and the fan and the Peltier cooler don't work to a maximum. So if you're going to use double or triple A batteries, or C batteries, or D type cell batteries, just remember that whatever batteries you use, make sure that you don't go over the amperes. So if you want the circuit to run on a certain amount of amperes, then you're going to need a bigger resistor to either connect it to the Peltier cooler fan, because that takes 3 amps, and the fan only takes 0.15 amps. So be careful when you're using batteries that you get the right amount of ampage. If I wanted 12 volts of these, I'm going to need more batteries, because this will only provide a certain amount of power. I mean, 1.5 volts of each battery. I'm going to need 8 of these to power up to 12 volts. Bear in mind, keep an eye on the amperes limit. This is 9 milliamps, so it's less than 1 amp. So whatever batteries you choose, just check the amperes, and if you're running more amps, then you're going to need bigger resistors to control the amount of current, in particular the Peltier cooler and the fan. As obviously, if you use weaker resistors, or you don't use any resistors, you're more likely to blow those components. So make sure you get the right sort of voltage for the desired electrical components you're going to use. And what I would suggest is, like I did before, I made my own circuit, and I sort of recalculated using Ohm's law, which I described to you, and to find out what sort of resistors you're going to need for your circuit, so you don't damage the components. But for the time being, I'm just going to use a good old cigarette lighter. Now you can get, I've got these, and basically to strip this out, you're going to need a cross point screwdriver first. As you see, there's this little screw here. You use a cross point screwdriver, and you basically take off the screw. The screw will then eventually fall out, and then here you unscrew the cap. There's a screw here that comes out with the tap. Then there's the inline fuse. Very important that. This is rated at 3 amps. I am running this over 2 amp system, but ideally I'm going to change this fuse to a 2 amp instead, so I don't damage or blow the components. Here you'll empty this part here, and then there'll be a spring here to provide the tension, and then carefully using a thin screwdriver just prise off the ring like so, and as you open it you shall have the contents inside. As you can see, if you look closely, this middle part here is the positive side, and this part here is the negative side. So basically, using the wires, you need to solder the positive side here with the red cable, and using the black cable on this side on the negative side. Okay, and what we're going to do is we're going to solder the cable, the red cable here and the black cable here. So you can see the middle part is the pos, the outer part is the negative. So what we're going to do now is we're going to use the soldering iron, and we're going to solder those parts together. So we're going to, before we solder, I'm going to get my cable, and I'm going to cut round about 3 meters of this cable. Then we're going to use a set of pliers, and we're going to cut the desired length you want. Also, I'm making this 3 meters, you can make it shorter. And we're going to do the same again to the black wire. So now we've cut the wire, we now have the desired length of the wire. And now what we're going to do with these wires, what I've done is, using a set of side cutter pliers, I basically cut off the outer cover of the wires, and basically I've stripped the outer cover to expose these copper wires. I've done this on both sides of the red and black wire, so now I'll be able to solder each parts of the wire together. And to do this technique, now ideally if you've got proper wire cutters, basically strip the outer cover safely without damaging the centre core of the cable. But basically I'm just going to use the side cutters, which is another method you can if you haven't got any proper set of wire cutters, and basically just cut the outer cover all the way around, and then once you've got it, you just put a firm grip and just pull the wire out just like that. That basically gives you the outer core itself, nice neat cut. Okay, you only need a cut around about the length of around about ½ an inch, so you don't need too much. If you do cut too much, you can just always cut off the remaining copper wire down itself. Okay, it's quite easy to do. Okay, and there's one on the cable itself here. So basically what you do is just clean them up by twisting the wire, even strands, so you don't get any loose strands on there, so keep it as one solid wire. Okay, so you should have nice neat copper things on both sides. Okay, so that's the cable now cut. What we're going to do is we're going to solder the red cable first, and then the black cable. Is with the bare metal, always put a layer of solder onto the wire itself, because one, it provides good conductivity. So putting a small coating of this solder will provide good electrical contact. So basically what you're going to do is you're going to carefully
carefully apply some solder, and basically you're just going to coat a little bit of solder all the way around to all the to the wire itself. Okay, carefully not to burn the wire off. Okay, just put a little bit of coating of solder, which will give a good connection. Okay, and then we're going to here connect the wire onto the positive side, which is here. We've connected to the positive side, and we're going to apply some solder onto this part here, like so, onto the middle part. Carefully apply a bit of solder, carefully, and basically you're just going to apply some solder like so. If you haven't put enough, just put a little bit more. Okay, but try not to put too much. And basically what you can do is apply some solder to the connection. Okay, try and get a really good contact, a good blob of solder, nice and neat. Carefully, not too much till you burn the wire, and just work that solder in. Like so, work it in, and then you should have a nice soldered part. Don't touch it until it let it cool down before you start touching it by all means. Once you're happy, you've got a nice soldered part, you're then going to put the wire on this part here, on the negative terminal. So again, coat your solder onto the wire, okay, and just evenly coat a nice layer of solder between the wires so you get a good contact, like so. Let it cool down, and then you're going to put the cable on here, apply it to the connection like so, and then we're going to put a nice blob of solder through here. And there you go, you've got a nice contact soldered up like so. And basically you're done on this part. Then allow it to cool. Don't touch it because the wires might be still hot and the solder might be still hot. So give it about a good 5-10 minutes. Once it's cool, as you notice, before I take it apart, is on the outer cover there is a wire coupling here. So basically take off the coupling like so. And then at the other end, you want to feed the wire through this coupling, nice and easy. So you feed it all the way through, like so, and align it to the recess. Okay, you don't want to have too much tension, but basically now that's aligned. You then put the outer cover like so. Then put the screw in place, tighten her up, place the ring like so, then insert the spring, let it slide down, put in the fuse. I'm putting in the 2-amp fuse, and then connect the tip end for the positive side to the screw, line it up like so. That basically gives your plug end,
just like that. So now you have the power source. If I'm just using batteries, then I will get something like one of these connections, and then do and obviously soldered the positive and negative side on the wires, which if you prefer to have a battery running, but I'm just going to use a cigarette lighter like so. At least it's going to inline fuse and it's nice and secure. Basically, one thing I didn't describe to you is I wanted to have the main wire to go through the Peltier cooler element and the cooling fan. I wanted to just change the circuit slightly by adding a quick release connection. So basically, if I don't want the fan to be operated or the element to be operated, I can basically switch that off by not connecting the cigarette lighter. So I basically, with the main wire, I then can quick release. So like this operates like a switch, right? So basically this is my main wire here, and basically that will apply the fan, and if I want to not use it, I basically quick release that, and there you go. I just leave this hanging off and then have the fan not connected to the battery or cigarette lighter. So basically I can switch it off that way. So again, this acts like a switch. There's no requirement to add an electric switch if you wish, but that just depends. But again, this is not highlighted in the diagram, but again, for items like this is don't cost very much to do, and it makes it easier for you to, if you want to connect the fan and all that. So what we're going to do now is do the same process, cut these ends off, and then join them together. Okay, you then you can either join up like so, or by crimping, or you can use bullet connectors if you wish. But I basically are going to wind these together like so, like that. We do same on the negative side. Basically twist them round together. Okay, nice and neat. Again, you can use bullet connectors if you wish to make a neat sort of thing, but basically what I do now, I will then solder these parts together. Just smear some solder on there, nice and neatly, and just try and cover all the wires on the salt. Cover all the wires without burning the wire. Okay, and just coat them like so. If the wire starts to get hot, stop, let it cool down. Okay, once it's cooled down, just apply some more solder. Basically what you're trying to do is you're trying to penetrate some of the solder through the wire. Okay, so just coat that entire area as much as you can with solder. If the wire starts to get hot, stop, because you don't want to burn the wire, because you can easily burn the wire with the soldering iron, so don't damage the wire. Again, apply some more and just keep coating that wire full of solder. Okay, so now what we do is now we do the same on the other side. We coat that with some solder. Alright, so do the same for that side. Once that's done, we then put some electrician's tape or something like that to cover the bare metal. Okay, like so. And just wrap that around so it protects the metal from touching the other wire. Alternatively,
you can use double end connectors, but make sure you get the right size diameter of wire. I believe that these are 0.5 to 1 millimeter wire, size diameter wire, so these fit perfectly. Okay, and it's a lot more of a neater job and gives better protection as well to prevent exposed wire. So basically this is the cable that I've done. To reinforce it and protect it, I use a bit of electrician's tape. Wrap around with a nice even twist, like so, and just it gives a nice covering, so it gives a good protection there, like so. That's basically the cable now done. So we grab our ASI120, okay, and you see the 4 screws that I mentioned, okay, and what we're going to do is before we start soldering stuff together, we want to place the main components installed. Now with this Peltier cooler, I've basically figured out which one's the hot side and which is the cold side, and the one way to tell is with the indication of the serial number in the front. That is basically the hot side where the heat is extracted off, and the cold side here is just plain. Now if you bought one of these and you don't know which side, I would test it out with the tester battery unit, okay, and just test, see if it works by applying putting the positive and the negative lead connected to the battery terminals, and just figure out which one's the hot side and which one's the cold side. Most of these devices is usually the printed side means it's the hot side, so the cold side's here. So that's what we want. We want the cold side to be aimed at this part here, like so. So basically we want that full contact back end, so you're going to get the cold air stuff and all that. Before we start putting together, grab yourself a heatsink. Now this just depends on what size heatsink you get. This one's like 8mm thick in obviously height, and basically this will fit directly onto there, like so. The good thing about this heatsink, because it's related to a CPU processing chip, this was part of a kit. I don't know which processor it would belong to, but I'm guessing it's an IE core processor chip. I'm not sure, but the good thing is it has an adhesive backing, which is a thermal adhesive backing. So basically I can now peel off the backing off here, like so, and basically what I'm doing is I'm going to apply on the hot side and apply the adhesive on there on the heatsink, like so, nice and squarely. It doesn't have to be spot on, okay, and that basically gives me my heatsink unit. So now I place the heatsink there, like so. So basically now the hot plate is, the cold plate's on this side, is now on the base, like so. And now what I'm going to do is place the fan over the top, like so. Remember that this goes a certain way, so this side here, this basically flips around like so and goes on the top of the heatsink. Now don't worry, make sure you've got the fans that's got the inside here, there is a little gap, so basically the bare wires can feed through here, and basically this can fit flush on here without the veins trapping the heatsink. I get my 25mm long screws with the basically with the washers and all that. It just depends what size bolts,
but I measured it across and it does tighten up quite nicely on these. Put them in place, finger tight first. You may move the heatsink, but place the screws in first, and then we can readjust the heatsink and the Peltier cooler. So basically we now rejig it so you get it all nice and centered, like so, and then you just tighten up by the finger, because you don't want to damage the M4 threads on the camera. And basically you want to get it so it's all sort of square, nice and even. It does take a bit of time, and then once you've got it squared, okay, you carefully get your Phillips cross point, and you basically just tighten up the screws. Right, try not to over tighten them so that you damage the threads. So now you'll have your Peltier fan, like so, nice and squarely. Right, and that's nice and secure, that's going nowhere. And just check the fan, see if it's not fouling against the heatsink, which shouldn't be, and it's not. And basically that's your main unit held together. And basically now what you're going to do is you're going to solder the cables like I've shown you on the diagram and the circuit diagram, the same way. And the reason why I've connected this part first is that once you solder the bits together or connect the bits together, then you can cut off the amount of wire you need, so that you don't want too much wire hanging off or hanging loose. So you can cut down the wire, and then you can guess, because you want it all nice and neat, you don't want it all tatty and scattered about, and then you can rejig and resort out how you want it. Top tip, I would recommend that you try and don't have too much wire wrapped around here, because the whole idea of this heatsink is to dissipate the hot side or the warm air outwards, so it gets it extracted away from the camera. So you want this gap here to be sort of clear away, so you got a nice basically gets all that trapped air of warm air to exhaust out, and obviously the fan will help to speed up the process. Okay, once you trim down the ends to a desired length you want, okay, we've now cleaned up, we've just pulled off the cable carefully so you expose the bare wire and clean them up by twisting them. This is when it gets a little bit tricky, but bit of patience and taking your time will prevent you from making big mistakes. So before we connect the main wire to the separate strands to form the parallel circuit, first off you want to install the resistor on the positive lead of the fan. Alright, so you can protect the fan. And basically it's all you do is get the resistor, carefully just cut down the length you want. Okay, just cut it down. Okay, so you get a nice sort of length part. Basically you want to solder this part of the resistor. It doesn't matter which side you turn your resistor around. It goes both ways, and basically you want to solder that part of the lead here first. So get that out of the way first. So we just put a blob of solder here onto the resistor. Be careful not to overheat the wire and the resistor wire, because you can really burn the wire and create an open circuit. So just a blob of solder on that part there, and that's the resistor now installed and secured. So it doesn't take much effort to damage these wires. Now soldered the cable, the fan positive resistor to the Peltier cable as well on that side as well. Okay, and now we're going to, you can either do the old process of crimping these two wires together, or you can use a coupling and do it that way. Now you can see now I've put, you can either crimp it like I did with twisting the wires together, but usually it's not always a good contact. But I use these connections, and that's now for the complete circuit. Now what we're going to do is we're going to test out the electric circuit, see if it's working before we start reinforcing the wires here, particularly near the resistor side, and then put the main armament on the main loom itself. So first off, we're going to test it out. I'm using my my battery. I've already got an adapter to put in the 2 amp supply. This is the cable that I get, which is a surrogate lighter followed by a little plug, and I can connect that directly onto the battery itself. Obviously there's some charge in there, and then we're going to apply the main line first. Okay, I've got some power here, and then now we're going to put in the quick release, and there you go. The circuit's now running fine, and you can see the fan and the Peltier cooling fan is now working, which means the circuit's working really good. Now because it's a 2 amp supply, I don't want too much ampage, because if you do, you'll have to put a bigger resistor to your components. So at the moment the fan is working to a treat. I can now feel the cold air. That's quite powerful, that. Basically what it's doing now, the Peltier element is providing cold air to the barrel, which I can now feel. Yep, I can now feel that the barrel is starting to get colder. And well, that's getting ice cold now. At maximum speed, which is cooling the excessive heat coming from the other side of the heat sink from the Peltier coolant. So the fan's now cooling it down. So what we're going to do now, we're now satisfied that the fan is working and the elements working on the thing. We're going to reinforce the cabling. Now I've reinforced the cables a little bit, making them stronger so it secures the resistor a little bit better. You can see now it's looking a much more neater job, and it's a lot more sturdier. And basically, again, keep checking the supply, making sure that the circuit, when you're putting this cable, make sure nothing's come off, and basically just clip on the power. And yeah, circuit's working. And what we'll do is now we're going to reinforce this whole cabling again. Now I'm wrapping the armoured wrap to protect the cable, making sure it's all clean and tidy and protects the cable. This will take a long time to do, so I suggest you, whilst you're doing it, have a fag or a few beers just to ease off your patience, because it does kind of take quite some time. Also, just to do a 3 meter length cable, literally taking me quite some time, about an hour, and so I'm almost at the end of the cable, so just keep going until you've gone to the very end and to complete the main cable. Right, that's the main cable complete. It's wrapped all the way up to the end, and my cable is now complete. You may wish to use a bigger diameter cable just to reinforce it, to double reinforce it, but I think this is strong enough anyway. Again, I've done the same to the camera, armoured it to a point so it's secure, but I will be putting a thicker cable in here just to reinforce that, so I get no movement of the resistor and all that. So basically now I will connect the battery, and then I'll connect the lead here. Right, so the reason we're doing that is just double checks once we're wrapping we don't have damaged the cable and all that and so forth. And then basically we're just going to plug her in. Luckily this connects one way, and voila, here you have now the fan and the Peltier cooling element now working simultaneously. What we're going to do now is we're going to test it on Shortcut 2 and compare the results of the noise and all that to see if there's any improvement. So again, we'll proceed further. Now, after doing further tests on the design, I tested it quite some time, and the Peltier cooling system did actually work, but it wasn't a massive difference. So obviously it's eliminated some of the noise, but it wasn't that great. And sometimes when the fan was rotating for about a good hour, it started to warm up. Because of the Peltier plate, this plate here has a cold side and then has a warm side here. Now the main problem I noticed is that the warm side, where the heatsink is, was warming up that much that it was actually warming up the entire camera. And what was happening is, as that's warming up, it was affecting the cooling side of the Peltier. So after doing a series of tests and a lot of thinking and all that, I did a bit of trial and error, and basically I come up with another modification that will help to improve the cooling system. And one thing I noticed, it does help if you install another heatsink, and what that does is it enabled the cold side to get onto the camera and also allow the cooling of the fan to get to this end as well, and provide the cold parts of the camera. So it's easy to install. Get the one that's sort of similar size. It's round about, I reckon, round about 35mm square. Alright, and it fits perfectly onto the Peltier element itself. Basically what you do, you basically take off the backing, like so, and basically you place it centrally as you can on the Peltier cooling system. Then the actual Peltier gives out like an 8mm clearance, so you're going to need to use longer bolts. Ideally use stainless steel bolts so they don't rust. And basically with that is that what you can do is
get them around about 35 millimeters, or depending on the components you're going to use, just check the sizes of the screws itself, and basically you slide it on top. Slide it on top, screw in nice and squarely as possible. It will go in there, just takes a bit of time to get it assembled properly. Nice and easy. You can sort out the gap and all that. You just got to get it in nice and flush. If the Peltier moves slightly, just move it in place. Once you've got it in place, you just carefully tighten up each bit, nice and flush. So just keep tightening it. Bit by bit. Now you notice I've got some washers at these ends here, but basically I've got these bolts slightly bit bigger. They may fit on a 30mm long bolts, metric 4 bolts, but I wanted to invest on a fan guard later on once they become available. At the moment there's the parts I'm still waiting for. So basically I'm going to fit a handguard over there, so that's why I need the extra clearance. As you can see, I'm slowly tightening up bit by bit, and there you go. Basically now you have 2 heat sinks now. So basically now when the fan's rotating, it will expel the heat from the hot side and dissipate the heat, and on the cold side the fan can still get to at the gaps, and basically the cold air will reflect to the element on the inside and providing extra cold sort of air, which is what you need. As the cold side basically conducts onto the heatsink, that will provide the cold side on there and stop it from warming up the case. So that's how I got round to it. And basically now I'm going to show you how it performs on the laptop, and it has made a massive difference, and you will soon see why. Okay, it's made the camera slightly bigger, but end of the day you want to get the maximum performance as you can possibly can. So what we'll do now, I'm going to show you now how it performs on the laptop. So got the camera connected, and we've basically the good thing about this system is I can use my power tank, my 7 amp power tank, and this will quite happily run the fan and the cooling system really well. At the moment it's running really fast, the fan, and now I'm starting to feel the camera getting cold now on the main body, which is a good sign, because basically what that's doing now is that all that cold air is getting to the body and it's cooling it down. So as you can see here, there is noise on the camera, but it's a much darker image, so there is a lot less noise than there is. It's on a 5-minute exposure. So the image is darker, but don't forget this is in my spare bedroom, which means that it's around about 22 degrees in here, so it's quite warm. So you're gonna get noise no matter what. However, if you take it outside, all this noise and interference will be a lot more reduced, and you'll notice it straight away. But it's still pretty impressive for a 5-minute exposure, and it's reduced the noise no end. The good thing about this system
is it will not fog out your CCD, so it won't turn it proper ice cold. Because what happens if you overcool it, you'll freeze up the CMOS chip and fog it out and make it worse on your images, and you won't be able to image. So it's a very good system, and it seems to be working quite well. It's cooling down very sufficient. Hence with the dual heat shield. So basically the fan is working at high speed at 5,500 RPMs. Basically the Peltier in between on the hot side, basically the heatsink on the top will dissipate the hot side, and at the bottom the heatsink will get the cold part of the Peltier, which will cool down the camera main body. So it's running smoothly and reliable, basically what I wanted. And I've had this camera running around for about an hour, and I've had no running problems whatsoever. Okay, there's noise there, but it's a lot more reduced. It's a much darker image, because this is what you want to do, try and get all this image much darker. But it does work, and it just proves that a simple mod like this that costs you not much money, and you get some decent results. So yeah, I'm really impressed with the thing. The settings are the same, like that. We've now tried we've got the camera without the cooling, and as you can see, the same exposure setting of 300 seconds, which is a 5 minutes exposure, and you can see the actual dark image that I'm taking is very, very pixelated. There's loads of false colour everywhere, and you can see the noise is so bad it actually illuminates the entire screen. So this is the reason why I'm trying to say about the ZWO ASI120, is that if you're using it for deep sky images, this interference is unbearable, and sometimes it can be very hard to try and as you can see, it's just gone into another frame, and you can see now a good clear example. The more of this noise, the more it just fades out the dim objects on screen, and also it's just changed exposure, and you can see it's unbearable. And this is the reason why I wanted to start looking into using the camera for some adequate cooling. And now obviously touching the camera itself, it's actually quite hot because the noise build up inside, and you can really feel the heat coming off that camera. So it just shows you that 5 minute exposure on this camera or more, and more of this noise is so bad. So, which is a shame really, because alright, it was only as a planetary camera, being an auto guider as well, which can be used, which is alright, but I just wanted to go that little bit further. I just wanted to find out how far I can push this camera, and obviously with this mod it just proves that one thing, it does actually work. Now this is without cooling, but if I plug it in onto the battery and all that, this will reduce the noise down a lot more. But what you have to do is, when you do mod your camera, is once you start using it, switch on the fan, alright, the fan system, and let the camera slowly cool down, and so you'll get lot less of these pixels and this white noise, and you can see it straight away. It's absolutely atrocious without the cooling. So this is the reason why I mod it, and I'm glad that in a way my version does work. And again, it does work, and for not much money, I seriously recommend that everyone should try this mod. You don't have to strip out any of the electrics in the camera, and there is no requirement to take it apart. Again, with these 4 screws fixed in with the two heat sinks and the Peltier element itself, and then the good old fan. It really is quite a really good system here. Again, I wish I had known sooner about putting a secondary heat sink, but again, it's trial and error. I had to work it out, find out what the problem was, and that was the problem. Basically, all the heat coming from the actual first heat sink at the top, that was transferring the heat towards the camera. So basically, with this secondary heat sink, basically the cold side will provide the cold stuff to the element, and also with a certain slight gap in between the sides, not only does the fan will also provide the extra coolness to cool the cold element, as well as exhausting the warm air coming from the hot side of the element. So basically, this will control the cooling down to a much more manageable level, and quite impressed really. Very simple to do. Please, everyone, just undertake this modification. You know, it doesn't cost a lot of money, but follow the guide that I've described. You've got yourself a very good deep sky imaging camera for not much money, and please use it by all means. I am impressed with this camera through and through. So easy to use, so easy to handle, doesn't cause much weight issues, even with all the stuff added on, which adds a bit of weight. Probably add around another 40 grams, but it's not much. It is manageable, and it's just weighs around about 80 grams, and it works just a treat. The battery life being only drawing 2 amps per hour, and you can see straight away with that drawing that 2 amps per hour, you know, you can get quite a lot of cooling time with this camera. So, and the good thing is this will do not use external power to the laptop, so it increases the laptop life of the battery. So this will run off an external supply, and the good thing about this system is you can always disconnect it, so you don't have to use it all the time, only when deep sky imaging. But again, very effective camera within budget for most amateur astronomers. Hopefully, please try this modification out. By taking the dark exposures, prove one point that it does work, and I can't wait to use it on taking live images. But however, bear in mind it takes a while to cool down, but once it does, it will eliminate most of the noise. But I am in a warm room, so that doesn't help a bit. If this was outside, the noise levels would be a lot less. But again, it does work, very effective, very cheap to do, very easy to do, and please try it by all means. And again, please try it out. Thanks again, thanks for watching, and clear skies to you all, and look forward to another guide. Goodbye.